Hi, I'm Edgar Thornton. This is Todd Jones. This is Wes Fabyan and Alex Wendland. We are Team 15. We decided to create a laser harp. We like lasers. We wanted to do something cool with music. And so we made this.
One thing we wanted to do is take the design of a laser harp. Some of the projects that we had encountered before had like a row of lasers, sort of a one-dimensional thing, and we wanted to be able to add to its capabilities, make it a two-dimensional thing, be able to play, instead of only playing 16 notes with 16 lasers, fold it this way, have a grid so that every intersection is a note, and play 64 notes instead of 16.
So this is the laser harp that we built. We designed the frame in SolidWorks, and then we used a laser cutter in order to cut the acrylic and form these intersections. Then, so what we did is we put 8 lasers on either side and 8 photoreceptors to receive the laser beam. And then what we did is we took straws and covered them in electrical tape in order to provide a dark environment for the laser beam and the photoreceptor.
One of the most important things we wanted with the laser harp was its ability to self-calibrate for any light environment it was in, so we could take it to different rooms and it'd still work. And what that required is doing not hard-coding resistors in to the photoresistors so that the Arduino would read the getting blocked as a 1 or a 0. Instead, it could read a full analog read and get 10 bits of data from each photoresistor. Unfortunately, the Arduino only has 6 analog in pins, but we have 16 photoresistors. So to do that, we would need some way to get all 16 photoresistors in to be analog read by the Arduino. We came up with a solution that relied on 16 NPN transistors, which sets up the photoresistors into 4 different channels with 4 photoresistors per channel. That allows us to toggle the various channels high to low, where we toggle one on at a time, and then the Arduino can read in the 10-bit analog value from each of the 4 photoresistors per channel. And over 4 cycles, it's able to read in all of the photoresistor values. What that allows us to do is the first time that it turns on, the whole thing keeps the lasers off, which we use a relay to control the lasers, and it gets a low value, then it turns all the lasers on and gets a high value, and it decides a cutoff value in between there so that it can accommodate any ambient light. With that, we're able to make it so that it's self-adjusting, self-calibrating, and if it ever breaks, we just restart it and it can handle the new light levels. The laser harp functions as a MIDI keyboard. We have a MIDI output here, which is controlled by the Arduino, which goes into a computer running a MIDI music synthesizer. So when we play anything, the Arduino detects that the intersections are being tripped, and then our MIDI synthesizer plays the notes on that channel.
Yeah, and so what we decided to do for the final part of the project was make sure we knew sort of where each intersection took place, and then better yet, what note we'd be playing whenever we decided on a particular intersection. We think this is really cool as a musical instrument because it is essentially a grid keyboard, sort of like taking a piano and putting it in an 8x8 arrangement rather than a line. And so this has a lot of really cool music theory implications, we think. So we think it'd be a lot of fun to maybe continue with it as a project.
Yeah.